So this is the air track, and this track is a great way of showing um, linear momentum. And basically, what happens is that momentum is conserved, meaning that the mass and velocity of an object or two objects that collide will continue to be the same even after the collision. So either object, in this case, this is these are the elasticity of these two objects are one. So if I collide these two objects together, they will bounce off of each other and go in the opposite direction and continue at the same velocity because their masses are the same. So let's do that one more time. Notice that. Let me go ahead and turn on numerical data for the gliders. If you look down here, the velocity of the glider 1, which is the red one, will be 5 meters per second. And the velocity of the second glider will be negative 5 meters per second. Both objects have the exact same mass, 2 kilograms. One is just moving to the left and the other one's moving to the right. So when they two collide, you notice that the velocities simply change direction. However, they remain the same magnitude. Now, what happens if I change the mass of the object? So just to make it nice and easy, I'm going to take this mass and make it 3. And in this case, I'm going to take this object and make it half of the mass of the original object. Now, they're both going to be traveling at the same velocity. Now, this object is twice as massive as this object. They're both going to start at the same velocity. Let's see what happens to the final velocities of both objects. So the two objects will collide, and they will bounce off of each other. And in this case, you notice that the heavy object slowed down, while the less massive object sped up. Okay, so what's happening here is that because this one because object 1 has a greater mass than object 2, its velocity will go down. However, object 2 has less mass, so the velocity will go up to conserve momentum. So let's do this again one more time and see if you can predict what the velocities will be. So we're going to take this and we're going to make this 3 kilograms. And in this case, we're going to take this way down to 0.3. So this is 10 times more massive than object 2. So what do you think will happen to the velocity? So this says the energy is going to be conserved. The kinetic energy is going to be conserved, meaning in this system, the total kinetic energy will remain the same. So let's see what happens to the object. Pause the video, see if you can predict what will happen. Okay, let's see what happens to this object. To these objects. Were you correct? Object 2 slowed down, object 1 slowed down, object 2 sped up. The total kinetic energy remained constant. Let's see this with our, let's turn on the total momentums. So look at the total momentum being mass times the velocity. We can even show the momentum vectors if we want. So notice that the momentum vector here, the mass is small, the velocity, the mass is small, the velocity is 5. Here the mass is large, the velocity is 5. Now, because there's greater mass, this greater mass in the direction that this mass is moving, or the momentum, or the direction that the mass is moving, is actually in the positive direction. So it's going to slow down a value equal to the momentum of this other object. So let's go ahead and have them collide. Notice that the total momentum remains constant. All right. Now, if we turn off the elasticity, so if we take this elasticity and we make it 0, meaning there is no elasticity, when the two objects collide, they're going to remain stuck together. Let's see what happens. So you notice the total momentum remains the same. All right, so let's do this one more time. And this time, let's make them have the same mass. We're gonna make these both 3, make it easy. And this time, this object's gonna be moving much faster. And since this object is moving much faster, it's going to have greater momentum. Which direction? Let's turn the elasticity back up to 1, meaning when they collide, there will be no loss in kinetic energy. So let's see what happens when these two collide. Okay, one more time. When these two collide, notice that all that happens, because there's just zero loss in kinetic energy, the kinetic energy of one is transferred to the other, and the kinetic energy of the other is transferred to the first. The momentum remains constant. The total kinetic energy remains constant. Okay. Now let's go ahead and, since we have different different velocities, let's go ahead and change the mass of, let's leave that high, and let's change the mass of this. So the velocity of object 1 is twice as moving twice as fast as object 2. So let's make this half as massive. So I'm going to change that, and elasticity is still 1. Notice that the momentum vectors are both the same. Okay. So the momentum vectors are both the same. So when the two objects collide, one moving faster than the other, notice that the momentum vectors remain the exact same, just in opposite directions. Let's do this one more time. Notice the kinetic energy is 75. It's 75 because the object is moving a lot faster than the first. The velocity is 10. This one is -5. So we're going to make these collide and see what happens to the velocities. Now the velocities, the magnitude of the velocities remains the same. However, they simply change directions.